Okay, let's take a look at another example here. This is one of those classic pre-calc textbook problems that you can find in any pre-calculus or math analysis book. All right, so an open box is to be made with a square piece of material, 36 centimeters on a side, by cutting equal squares from the corners and turning up the sides. Write the volume as a function of its height, and part B, determine the domain. Okay, so we definitely need a picture for this. So let's draw a square to the best of our ability. There's a square. And this square, if you go back and read the problem, right, it's 36 centimeters on the side. Okay, 36 centimeters on the side. Okay, so I'm going to label my square here. This is 36 cm, 36 cm. Okay, so what are we going to do with this square? We're going to cut equal squares from the corners, and then we're going to turn up the sides to fold. We're going to fold the sides to make a box. Okay, so we're going to also cut squares. I'm going to just dash it here. We're going to cut squares from the corners, and we're going to form a box, right, if we cut the dashed line. Okay. All right, so part A, we're asked to write the volume as a function of its height. So in order for us to calculate volume, right, we know the volume formula in general of any particular prism is the area of the base times the height, okay? So take a look right here, right? The base area, if you can visualize, if I may cut some dashed corners over here, these dashed lines right here represent where you're gonna fold. This would be the base area, right? The bottom part of the box. So that's your B, if you will, okay? All right, so we need some variables over here, right? Because we want the volume as a function of height. So the variable I'm going to use is I'm just going to call this X. If that's X, this is X, this is X, right? Because these are squares here in the corner, okay? All right, so I want the volume as a function of its height. And if you think about it, right, if you fold this box, you fold it up, the height of the box is just X. All right, the height of the box is just X. So we already have the height of the box, okay? So this guy right here is our height. All we need is our base. So what is our base? Okay, so back to this figure right here that's shaded, right? This is our base. So if we could figure out the length of one side, right, we just need a square. Well, it's not 36, right? The length of this is actually not 36. It's 36 minus 2x, right? Because there's x here on the side on the right. There's x here on the left. It's 36 minus 2x. If I ask you, what's this length right here, right? This is also 36 minus 2x, okay? So this is 36 minus 2x. And this is also 36 minus 2x. So the area of the base is just 36 minus 2x quantity squared. And there's my volume as a function of its height. Okay, so if I can box around my answer, there it is. Volume as a function of height. Okay, now part B is going to get a little bit trickier because it forces you to actually think. Oops. So let's take a look over here for part B. How do I figure out the domain of this function such that it makes sense? Well, in order for this problem to make sense, right, the volume cannot be negative, right? And the volume also can't be 0. And the side length, right, can also only be positive. So what I'm going to say is that the volume has to be greater than 0, right? This is for the domain. I need to solve for the volume such that v of x is greater than 0. Okay, or I need to solve for the x such that v of x is greater than 0. So if I plug in v of x, right, I'm going to get 36 minus 2x, quantity squared times the height, which is x. This has to be greater than 0. Okay, so now you have to identify what kind of problem this is. This is a polynomial inequality. All right, polynomial inequality. And the way you solve a polynomial inequality, right, is just like how you solve a quadratic inequality. two ways you can solve, right? Way one is test on the number line. And if you remember, right, the way to test on the number line is you have to get the x-intercepts, right? So 36 minus 2x, quantity squared is equal to 0, and x is equal to 0. So my two x-intercepts, if you take the square root of both sides on this one, right, you're going to get 36 is equal to 2x. You're going to get x is equal to 18. And this one is just x is equal to 0. Okay, so after you get these x-intercepts, right, you test it on the number line. There's 0, there's 18, and this is my v of x right here, right? So how do I solve this? How do I interpret this? This is saying, what are the values of x such that v of x is positive? That's what it's asking. All right, so if you remember, right, on the bottom part, I call it x. On the top part, I call it v of x. Now, normally I would ask you, hey, let's test points to the left of 0, right? And then tell me what my v of x is. But in the context of this problem, right, with testing, let's say, I test -1 right here, right? Plug in -1 into this original v of x, 36 plus 2, that's 38. 38 squared is a big number. 38 times -1, that's negative, right? So let's just go through the process, and then I'll come up with the final solution, okay? Let's say I plug in 1 over here, right? 1's between 0 and 18. 36 minus 2, that's 34. 34 squared. I don't know what that is off the top of my head, but I know it's a big number. And then positive number times 1, okay, is also a positive number. If you're wondering where I'm plugging it in, I'm plugging it into the original, okay, inequality. Let's say I plug in 20. If I plug in 20 into the v of x, 36 minus 40, okay, that's -4. -4 squared is a positive number squared times a positive 20, you're going to get a positive number, okay? Now, if this was just a normal polynomial inequality, when I say normal, meaning it has no context, there's no word problem behind it, what are the values of x such that v of x is positive? You might just say it's from 0, x is greater than 0, right? So over here, I'm going to make a check mark, but take a look at this one, right? Can x actually equal 20, right? Well, what happens if x is equal to 20? Well, going back to my original problem, right? 36 minus 2 times 20, right? This represents a side length, right? So, if you have 36 minus 40, you're going to get -4. You can't have a negative side length, right? So even though there's a check mark in this region, right, v of x is positive, in the context of the problem, it doesn't make sense. Okay, so this is the part where you really have to think. So even though you could say, oh, it's just x is greater than 0, right? X is greater than 0, x is greater than 18. Actually, the final domain, right, the real domain is just x is between 0 and 18. Okay, x is between 0 and 18. I forgot to draw those open circles. All right, so x is between 0 and 18. That's my final domain. All right. If you want, you can solve this also by sketching. Okay, so let me just show you way 2 really quickly. This one's a little bit trickier to sketch because, you have to remember all your properties of sketching polynomials. Okay, but let's just see if we this will be good review for you guys. Okay, so way 2 is also getting the x-intercepts, right? 36 minus 2x squared is equal to 0. You're going to get x is equal to 18. X is equal to 0. Okay, so these are your 2 x-intercepts. Now, for those of you who remember how to sketch, this is the degree of this function is 3, which means it's odd. The leading coefficient, right, is it's going to be, I don't know what the actual number is, but if you square this, right, x is going to be squared. A squared term times x term is x cubed. It's still going to be positive. And so the M behavior, okay, EB, is fall on the left, rise on the right. Okay, so hopefully you guys were taught that. If not, it's going to be reviewed again. All right, so these are my x-intercepts. Here's 0, here's 18, right? If the end behavior of the graph looks something like this, I would draw these end behaviors. And then remember, this 18 is a double root, which means that this multiplicity is 2. If it's an even multiplicity, at 18, there's going to be a bounce, okay? This multiplicity right here is a 1, so this means right here it's going to be a cross. All right, and roughly my sketch is going to look something like this, okay? And going back to the original problem, right? What are the values of x such that v of x is greater than 0? Well, v of x is positive here, right? It's also positive here, right? But v of x is negative here, right? And so, again, you might be tempted to say, oh, you know, x is just greater than 0 because it's positive. And if it's just a regular polynomial inequality, you'd be correct. You would say x is between 0 and 18, x is greater than 18. That's what you would say. But in the context of the problem, for it to make sense, x has to be between 0 and 18. Okay? So again, why can't x be 18? If you think about it, right, or if x can't be 19 or 20, right, it's going to make my psi length negative. And so I know this problem is a little heavy, but it's a good problem because you have to write something as a function of another single variable. It reviews all your geometry, and you also have to practice your polynomial inequalities.